All right, good afternoon, everyone. Welcome to this session on VMware's Virtual SAN. Welcome everyone online as well. My name is Bhumik Patel. I'm a partner architect at VMware. I focus on our joint solutions with Cisco. So today, in the next 30 minutes, I'm going to cover our Virtual SAN solution, which is a hypervisor converged storage architecture, and also give you a insight into our joint solution with Cisco UCS. So as we get started, let's do a quick recap on how some of the key trends, including virtualization, has affected storage, right? So if you compare to the physical workloads and the physical world a few years ago, we were very used to being a static mapping between applications, right, and your storage. So performing QoS and performing management of storage was pretty simple, simpler compared to in a virtualized environment because of the static mappings, right? The workloads were not moving around as much as they do with virtualization and things like storage vMotion, right? So with virtualization now, some of the challenges that you're looking to solve is because the way data is consumed by your virtual machines, by VMs, is through VMDKs. You're looking at this end-to-one mapping between your VMs and your applications and your underlying storage, right? So that's just one factor. Another way in which workloads have been affected by virtualization is specifically storage has been around IOPS, right? So from having sequential workloads or sequential IOPS to having more random IOPS with virtualized solutions, right? So as we know, magnetic disks and typical SATA, SAS drives are not the best fit for random IOPS, right? So and it's not just virtualization affecting storage workloads. It's also one other factor is change in the application trends, right? So we call this cloud-based applications, and specifically these cloud-based applications are they tend to be more scale-out in nature, right? So whether they are built with some specific storage constructs in mind, like availability or performance, and they affect their underlying storage differently than what traditional workloads used to be. And with that, we also see a shift in the underlying infrastructure, components from storage, right? So we obviously see a lot more flash-based solutions, whether they are, complete all-flash arrays or hybrid arrays, and even server-side flash technologies, right? And that's possible because, from a cost perspective, performance and IOPS, having more IOPS on a flash array has become very beneficial, right? So, and then you look at the other end of the spectrum where you have cloud-based storage or object-based storage like Blob, and maybe not that prevalent in enterprises today, but certainly looking forward, it's also going to affect the way we architecture our storage environments, right? So the way VMware approaches some of these challenges is through our hypervisor converged storage, and it's a critical component of our software-defined storage, which I'll cover in a second as well. But it's possible because the hypervisor ESX is sitting at it's uniquely positioned in the stack, if you will. So it's the first piece of software between the infrastructure and the application, right? So if you think about it, all the I/O from your application is passing through the hypervisor to your underlying storage. And not only that, through our integrations with the underlying storage arrays, right, whether it's external SAN or NAS or this unique hypervisor type local storage we are talking about today with vSAN, or even cloud-based storage, all the integrations that we've done with our ecosystem partners with APIs, we also have, ESX also has this global infrastructure level view. So it can look up to the application and look down towards the infrastructure, and it's uniquely positioned to be able to, provide this solution, right? So let's look at our software-defined storage and how vSAN and Virtual SAN fits into this. So there are three key components to our software-defined storage solution, right? The first is to be able to virtualize the data plane, right? So this is where you would abstract and pool all your underlying storage resources, whether, again, it's from an external array or a hypervisor converged storage, and to be able to do that in a logical fashion, where now you are able to apply, virtualized data services in a much more granular fashion, right? So some of the data services we are talking about here is replication, snapshotting, and we leverage all our ecosystem storage partners and heavily integrate with them through our VASA APIs and such to be able to provide that. But the difference here is it's done at a much more granular level, so it's done at a VM level or an application level. And then finally, once you have that, you need a policy-driven control plane, which is where which is what allows you to automate and orchestrate a lot of these things. So in this model, you're looking at a policy that is attached to a VM upon creation, and that policy stays with that VM throughout its life cycle, right? You can obviously edit that policy and change the characteristics and the requirements that that VM needs from your storage, but that policy can stay with the VM through its life cycle, right? So this is how you can push down the requirements from an application to your storage infrastructure and get that while you are provisioning the VM, all right? And we've obviously, as I mentioned, built a very rich ecosystem around this, and Virtual SAN is one component of this software-defined storage strategy, and that's what we'll talk about today. So what is Virtual SAN, right? So Virtual SAN is a scale-out storage, which is a distributed layer piece of software which resides in a VMware ESX kernel level, right? So on each ESX host, we have this on the kernel level. So it's a scale-out storage. So you'll be, it basically aggregates the underlying local storage, whether that's flash, PCIe or SSDs, or whether that's magnetic disks. And the idea is to be able to provide a balanced, flash optimized solution. And what I mean by that is, if you look at flash, as I mentioned earlier, getting high number of IOPS with flash is really cost effective, right? You could probably get high number of, an IOP less than a cent with flash, but not so much in terms of capacity. It's still very costly to be able to scale out and add capacity in just a flash-based manner. But you could do that with magnetic disks. Capacity is not an issue. Capacity with magnetic disks is very cost effective, but having more performance is not. So what we do is we obviously, as you can guess, combine the best of both worlds. So we, all the IOs in Virtual SAN goes through flash first. They're either read cached or write buffered, and then they're highly optimized by that flash layer, and then eventually we destage them to the magnetic disk for capacity. And the way we do this is we aggressively apply redundancy, right? So because capacity is not an issue with magnetic disk, we basically keep replicating across those magnetic disks to be able to provide the required availability and redundancy at the application layer, right? Another feature of Virtual SAN is obviously it's simple to implement. It's integrated with vSphere, but not only integrated with vSphere, but also deeply integrated with entire VMware stack, right? So if you look at features like vMotion, DRS, HA, storage vMotion, they're all interoperable with Virtual SAN, right? So if you have an existing ESX cluster and you're deploying Virtual SAN, all of these features work along with Virtual SAN. It's also integrated with our data protection solutions, VDPA and VDPA Advanced. So if you are doing backup and replication, you can do that on a Virtual SAN storage. VDI obviously is integrated with Horizon, and as you could see, a lot of this interoperability is also what drives the use cases, right? So we look at some of the use cases for Virtual SAN, and you look at DR as a service or disaster recovery as a use case, and it's interoperable with our site recovery manager and vSphere application solutions, right? So that's another advantage you have with Virtual SAN, is that it's gonna plug into your existing VMware solution. So let's look at some of the use cases, right? So at a very high level, one of the top use cases for Virtual SAN is VDI, right? You can now have your VM data optimized, as I mentioned earlier, in a flash optimized manner, and get more IOPS and scale out the solution, right? So that's a big one. We've done a lot of work with Cisco on a backup and DR as a service type use case. So I have a slide later on where it's a VMDC based architecture and DR as a service. And Virtual SAN is a target DR, target storage at the DR site. ROBO is another use case, branch offices, right? So if you are using like Cisco ISR G2s with the compute blade, blade module on that, Virtual SAN is compatible with that, and that's a use case where you could have a small number of workloads distributed out in your branch. And then obviously, one of the reasons why we have test and dev workloads highlighted here is being a new model of storage, right? It's a hypervisor converged architecture. We want to be able to make sure that our customers can, internalize the solution, and mostly around operational practices, right? How you manage your storage. It's going to be similar to managing ESX clusters, but now you're managing a storage product, right? So that's why, with this product, with this version, we are highlighting that test and dev and staging and hosting your management clusters, right? vCenter and Active Directory and such are a great fit for virtual SAN. All right, so I spoke a little bit about the app-centric approach. So, how is virtual SAN different, right? How does it put application in center, right? So, if you look at a traditional way of deploying VMs and storage, you basically provision your storage and you make that storage available to your VMs, right? That's how we are used to doing it. With virtual SAN, as I mentioned, you would define a storage policy while you are creating a VM. So while you are creating a VM, you could define what type of redundancy you want, what type of performance you would desire, and what type of characteristics that you're expecting from your storage infrastructure, right? And while you do that, it's gonna obviously needs to match with the underlying storage resources, right? Because you need to have those resources to be able to satisfy those requirements. So we do that dynamically as well. So you're going through a very simple GUI-based interface where you are defining and basically requesting all the characteristics, but you're also matching it. So what data store can provide those capabilities? So we do that while we are creating a VM, all right? So this, one obvious benefit is you would most likely not end up doing a lot of over-provisioning of storage, right? Because you are provisioning storage while you are creating your VMs. I mentioned it's a scale-out storage, so some high-level, numbers of capacity and supports up to 32 hosts per ESX cluster. So a virtual SAN cluster, it's a cluster-level feature at ESX, and it supports 32 nodes. And you can see some of the IOPS numbers and the VMs that it can scale out up to. All right, and I'll go into the architecture of virtual SAN right now. All right, so from an implementation perspective, it's really meant to be a simple implementation, right? So whether you have an existing ESX cluster or you're creating a new cluster, it's a cluster level feature you can enable. Once you enable that cluster level feature, you have two options to the way in which you can add your SSDs and hard drives to the virtual SAN cluster. One is automatic mode, which means virtual SAN is going to go and grab all the magnetic disks and all the SSDs that it can see and basically present a shared data store to your ESX hypervisor, right? And if you want to do it manually, like if an admin wants to grab specific disks, you can do that in a manual mode. So those are the two options. It's really a simple way to deploy virtual SAN, right? From a requirements perspective, it's a 3-node minimum requirement from redundancy perspective, right? And a witness node. So you need 3 minimum nodes. And in this model, right, there are 2 different ways this nodes can contribute towards a vSAN storage, whether they are contributing to a storage or whether they are not. You could have nodes that are not contributing to a vSAN data store, right? And the way we calculate storage capacity is just magnetic disks, right? Flash is not counted as part of the virtual SAN data store capacity. It's only the magnetic disks that count towards the capacity. You could have nodes that are contributing to the capacity. You can also have nodes that are not contributing to the capacity, just providing the compute layer. We highly recommend that it's more balanced, as much balanced as possible, for obvious reasons that if it's more balanced, then we are able to provide the highest level of redundancy, availability, and performance, right? Because now we don't have too much mismatch going on between the nodes that are providing storage versus not. Let me just go back. So from a network perspective, 10 gig is recommended, supported with 1 gig. One technical requirement I would mention is, you would have your own, vSAN network, and you need multicasting for that vSAN network to be working, right? All right, so I mentioned we leverage flash in two purposes, right? Read caching and write buffering. So all I/O that goes through the VMs, first they go to the flash layer, right? So we are doing write back buffering, and then we are doing flash read caching. And the split by default is dynamic, right? So we don't have we provide the ability for admins to say that I want to reserve X amount of X percentage of my flash towards read cache and X percentage of my flash towards write buffering. But by default, it's all dynamic. And we recommend we keep it that way unless you have an application that you understand your workload and you can change. And the reason is that if you statically change those configurations, then you are you might be over provisioning or underutilizing your flash, right? So if you say, for example, reserve your flash for 30% read caching, and you're not, if you're not hitting all those caching, then you're not using that flash for write buffering, right? So we recommend you leave that at default. All right, so let's look at the data store, right? So it's an object-based data store, right? So again, it's going to present itself as a shared data store, and underneath the data store, the way we have a construct of disk groups, right? So the way this local disks and flash disk SSDs are aggregated is via a construct called disk groups, right? So we support up to 5 disk groups per host. Right, so that's the support we have today in this version, and each disk group can have 1 SSD and up to 7 hard drives. So you could have a disk group with 1 SSD, minimum of 1 is required, and you could have 3 magnetic disks, or you could have up to 7. Right, so this is how you can scale up and scale out. All right. So I think we look at here. Let's look at the scale up, right? So you could have a host where you only have a single disk group, and then you can scale up by adding number of disk groups, right? So here you are adding another disk group, and you can do up to 5 disk groups per host. You can also scale up by adding more magnetic disks within a disk group. So if you don't have 7 hard drives up front, then you can add them within the disk group, and it will dynamically recognize that extra disk. And then lastly, you can obviously scale out by adding another host, right? And when I say it's a scale-out storage architecture, when you scale out, when you scale up or scale out by adding disk groups or hosts, you are not only just increasing capacity, but you are also increasing performance, right? So it's all part of that virtual SAN data store that's being bubbled up. And if you add another host, it's going to count towards both the flash and the hard disk. This is also a way to ensure that our failure domains are smaller in nature, in size, right? So if you have an SSD failure, then that disk group is not operational, right? You need that SSD because all IOs go through the SSD. You need the SSD to make a disk group operational. So by having these multiple disk groups, if an SSD fails and you have a disk group that is out of commission, you're limiting your failure domain to that disk group versus being a larger failure domain. All right, so let's look at how storage-based policies applied in virtual SAN, right? So I mentioned earlier a lot of the integrations that we do, even with our external arrays and partners, external array partners, is through our VASA APIs, and that's what we use with virtual SAN as well. So we have VASA API-based integration with virtual SAN and vCenter. This is how all the capabilities that virtual SAN can provide are bubbled up to vCenter, right? And we look at the 5 capabilities that we have today with virtual SAN, and from an end user perspective or an admin perspective, you'll have a wizard where you can choose, while you're creating a VM, you can apply which capabilities you want out of that out of your vSAN storage for that VM, right? So I think I talked about this a little bit. Let me just go back. And it's a storage policy wizard, so it's very intuitive. We are doing demos over there in our VMware booth if you would like to take a look at it. And as we move forward with our software-defined storage and constructs like virtual volumes in future, this is the exact same concept we use: storage, SPBM, storage policy-based management, right? So. Again, applying this when you're creating VMs and bubbling up the capabilities of your storage and dynamically provisioning it. So these are the 5 capabilities that we'll talk about just briefly, right? So first one is number of failures to tolerate, right? So this is the way we do distributed RAID, right? So by default, it's n plus 1, right? So this is the number of replicas we'll create, right? So you have 3 hosts. If you leave the policy default n+1 for any, and this is per object, right? So this is per VM object. So an object-based data store, as I mentioned. So this is per object. So you'll have 2 replicas for that object, and you can increase that, right? So you obviously need 2 n+1 number of hosts. So if you have three hosts, which is the minimum, and you say I need a redundancy level of 5 or 6, it's not going to match a data store, right? So you're out of compliance. So it's very intelligent that way. The second one is number of disk stripes per object. So this is to increase your performance, right? So this is basically if you are getting a lot of cache misses, then you can increase the performance because you have a number of disk stripes across different disks. By default, we don't do disk striping, so by default it's 0. By default it's 1, right? It can be 0, and you can do up to 12 number of stripes across different disks. The third one is forced provisioning. So as I mentioned, if you don't match the data store, then it's going to not be able to provision, but there might be some cases where you still want to go ahead and provision. So you understand that you are applying some policy that your data store cannot satisfy or meet, but you still want to go ahead and provision, then you can say yes to a forced provisioning option, and it's going to let you go through that provisioning. The fourth one is flash read cache reservation. So if you want to explicitly say that I want to give 20% of my flash for read cache reservation only because I understand my workload and it needs that much read caching, then you can do that, right? So by default it's 0 because it's all doing read caching and write buffering dynamically. And the last one is object space reservation. So you can basically thin provision versus thick provision, right? So by default, you could have 0 versus 100. So by default, it's all thin provision, but you can thick provision if you want. All right, so we looked at the architecture a little bit, and how do you consume this, right? So there are 2 ways for a partner or a customer to leverage virtual SAN. One is through our HCL, obviously. So we have our certified list of hardwares, SSDs, magnetic disks, RAID controllers, and you can build your own system. Or we have something called ready nodes or ready systems, where we work with different partners like Cisco, and we would have a recommended BOM created, if you will, where it will tell you exactly number of disk groups we recommend, the disk components and servers and so on. So you can just choose a ready node system. All right, so let's quickly look at our solution with UCS, right? So give you a preview of a reference architecture. We are working with Cisco vSAN and UCS, so it's C240M3s if you are familiar with the UCS rack mount servers, and you can see some of the characteristics, right? So in this case, we have an 8-node cluster. Each node has 3 disk groups because the C240 server can support up to 24 slots. So we have 3 disk groups, 1 SSD, 7 disks, times 3 is 3 SSDs and 21 hard drives. So we fill up the entire 24 slots. We don't need to do that. This is more like a high capacity type environment. You could totally be having less number of disk groups or less number of disks within those disk groups, right? We support up to 5 disk groups, but because C240 has 24 slots, you can go maximum up to 3 disk groups. And you could see some of the other components. We used the Cisco SD cards, mirror SD cards for ESX install through our auto deploy solution, and this is our this is one of the architectures that we'll jointly recommend. This is a bit of an eye chart. As you can probably tell, it's a Cisco slide. One of the use cases that we worked with Cisco is around DR as a service. So it's VMDC-based architecture. You can see that virtual SAN is used as its target storage on the DR sites, right? So you could use our vSphere replication solution, or you could use any, I think in this architecture, Cisco uses third-party replication solutions as part of their architecture. But when you migrate those workloads to a DR location, you could use virtual SAN as a target storage. So it's validated, and there's a if you go to that URL, you'll get the document. And this is the Cisco UCS solution accelerator pack information. So this is more for partners and customers where this is the bundle, that's the starter kit and the expansion bundles that Cisco has, right? So as you can see, there's a 4-node UCS vSAN bundle. And even though the requirement is 3 nodes minimum, a lot of times we see that it actually ends up being 4 nodes, because when you do a lot of maintenance operations, you want to take one host out, then if you have 4 nodes, then you still have 3 nodes in that environment. So that's what this is based off of, 4 nodes to start off. And the way, using this accelerator packs, the way you can scale out is either you can add another host, so you can see a node expansion pack there, or you can add another disk group, right? So you can have this 4-node starter kit, and you can keep adding hosts and disk groups as you scale out. All right, so as we close this off, I'm going to just touch upon some of the interoperability components that I spoke about, right? So VDI, right? So we've done a lot of work with our Horizon View and Virtual SAN. So we have reference architectures on how you scale out from a 3-node to an 8-node cluster, and how many VMs you can support with Virtual SAN. We also support Virtual SAN with Citrix and Desktop, right? And the difference is that when you do storage policy-based management with Horizon 6, which is our latest VDI solution we just launched, you could do this automatically. So instead of creating manual policies, this is integrated through a GUI-based wizard, all right? Another integration point we have is our vSphere application and site recovery manager, right? So if you are doing DR, and if you are if you're automating a lot of your DR operations using site recovery manager, and you're doing replication with vSphere application in software, you could use Virtual SAN as your storage, right? So when you go through the automation of SRM, it's integrated with Virtual SAN, so it understands that Virtual SAN is your target storage. So this could also be a use case where you already have an existing storage environment, but you could easily migrate and replicate your workloads to a DR site which is running on Virtual SAN, right? So it totally works, and we have some documents around this. So it's not meant to be just a Virtual SAN in a DR case. Both, you can totally have a mix of storage architectures. You can migrate from one to another. And the last piece of integration I'll talk about is the data protection, right? So we have a data protection solution, vSphere data protection, right? So this is for backup and recovery, and again, it's integrated with Virtual SAN, and you can leverage that as part of backup and data protection. We also have some attractive bundles. So if you purchase Virtual SAN with our backup solutions, you get a discount, and we have that available on our websites. So I think I'm going to wrap this up here. Hopefully some of the key takeaways from this session are to be able to understand Virtual SAN as a hypervisor converged architecture, and what type of challenges it's meant to solve, and what's the operational model it can support. And then obviously take a look at the joint work we've done with Cisco UCS, and understand some of the use cases that Virtual SAN can drive for you. Right? Hope this was informational for you, and if you have any questions, I'm going to hang around here. Thank you so much.